Part 2 of the Makita soldering iron. I've been very impressed with it, and I've been using it as my normal soldering iron since I did the last video. Very good performer. I can't find any faults with it, and I haven't had to use the Weller with its expensive elements. I was so pleased I purchased a second unit just in case, because it seems that this particular model has gone out of production, or is just about to, because there's a different type which all the sellers on eBay and AliExpress are selling. The actual soldering iron bit looks similar, but the control unit that fits on the battery is a bit different. Anyway, so in this video we're going to have a look at what's inside the controller, and I'll also show the 12 volt power supply I built so I could run it off the solar circuit in the house. So I'll pull the label off and see if I can get it apart. It's rather annoying that they put labels across the join in the case, but seeing as I've now got a second one, I'm not too bothered if I damage this one slightly, but that looks good. It's coming up alright without damaging it. I only need to take it to the halfway point, which is there, and 2 Phillips screws inside here. Okay, yes, it does come apart, that's good. Alright, so what do we have inside? Yes, the multi-pin IC and a MOSFET. Okay, so the MOSFET's obviously doing the temperature control. If I get my magnifying glass, see if I can read anything. Okay, so we've got no numbers. The MOSFET does have a number, probably meaningless, but it's D8575N, and the microprocessor, no idea. I mean, that's pretty much what I expected to find inside it, so no surprises there. Yeah, so if anything died in it, if the micro was stuffed, you'd be out of luck, but the MOSFET would be replaceable. That semiconductor down here, oh yeah, it's got a number. Yeah, can hardly read it. Oh, hang on, that's a 7/8. Is that a regulator? Oh no, it isn't. No, it's a 7150-1. Whatever it is made, or was made, 2025, 35th week. Okay, well, I'll put it back together and we'll have a look at the power supply. The things I want to show is why this iron heats up so quickly. So I'll take the tip off and power it up. And you might see it glow red. There you go. So we can see that's why it heats up so quickly. Yeah, I don't know if this is sort of based on a glow plug is used for a diesel engine. I've seen plans on the internet to make soldering irons with such things, but yep, that's why it heats up so quickly. We're getting up to red hot within a few seconds. Yeah, what I wanted to do was to be able to power the iron off my 12 volt DC solar supply, which I've got reticulated throughout the house. And the first stumbling block obviously is that the soldering iron needs 18 volts and the supply is 12 volts, so I used a switch mode converter. Now the other challenge was how to interface with the battery. My first idea was to get an empty battery case, which you can do on eBay and AliExpress if you want to rebuild your own battery. Problem is they're pretty expensive, around $22 to $28. I mean, just for basically a bit of plastic and the BMS board. So what I ended up doing was to just get a battery adapter and modify that. This adapter is actually for a Milwaukee battery to Makita. So I basically removed the bottom half of it and attached it to the box, so it just goes on like that, and we have a 12 volt soldering station. It works in the normal way, so power on and hold down the temperature plus button to get it started, and there you go. As you can see, the iron is heating up quite nicely, and very shortly that lead on the iron will dim once it's up to temperature. Yeah, there you go. So yeah, I've now got the same convenience that I had with the Weller, but running off 12 volts for free. So let's have a look inside the box. I've based it on a design which appeared in Silicon Chip for June 2003. It's a DC to DC switch mode converter using the Motorola MC34063 switch mode converter, which I've used in other things. It's a very easy chip to use and works very well, and it's fairly non-critical. I actually built this unit up some years ago as a 6 to 9 volt converter for use in the Model T, to experiment with running the ignition coils on 9 volts instead of 6. But to cut a long story short, it was just an experiment. It wasn't ever a permanent thing, so I had the power supply left over and I thought, well, rather than buy a new power supply off eBay, let's try and modify this for 12 to 18 volts. And that was completely successful. So to have a quick look at the circuit, we've got the 12 volt supply coming in. By the way, this circuit which they designed was intended to output up to 24 volts, but I've set it for 18 in this application. So basically the IC oscillates, producing a square wave of variable duty cycle, which switches the MOSFET on and off, and we've got the choke here, which is used to step up the voltage, and the Schottky rectifier diode, low ESR filter capacitors as normal. I've used fixed resistors for the voltage adjust. I tend not to trust trim pots, they tend to go noisy, and I mean, once it's set, there's no need to ever adjust it again. I did modify a few things because, as it is, this circuit can't put out enough current. So the current sensing resistor here is used to determine how much power you can extract from this thing before the IC starts to shut down, and that in turn depends on your choke and the MOSFET, etc, etc. So they've used 0.1 ohm 5 watt. I've used 3 lots of 0.1 ohm in parallel, because in this instance, with the output current of 18 volts at 3 amps, the input is 12 volts at about 5 amps. Instead of the fuse, I've used a 5 amp poly switch, much more, well, let's say, suitable for this application. Instead of the 16 volt Zener, I've got an 18 volt voltage dependent resistor, and the capacitor values I've beefed up a little bit. The diode and the MOSFET I've put on heat sinks, and I've also added an incandescent power light, which is actually on the 18 volt side of the circuit. It's actually a 28 volt 25 milliamp bulb, and yeah, a power switch. So that's about it. Yeah, the only other thing I'd mention before closing is this timer. The literature and advertising says it switches off 10 minutes in standby. Well, it turns out that there's no actual sort of standby feature as such. It just turns off in 10 minutes regardless of if you're using the iron or not. And I mean, when I first learned about this, I sort of wondered, oh, you know, how can they sense if you're using the iron? I mean, there's no, you know, switch in the holder, or the only other way they could do it is to actually measure the change of the temperature of the iron, because obviously if you're using the iron, the temperature is going to drop, but that's not going to be entirely reliable, you know, things like ambient temperature, etc. So yeah, it's just a 10-minute timer, like it or not. So yeah, you can get caught out and you realise the iron's gone cold, but at least it's quick heating. Every now and then, if I'm doing a long job, I'll press the buttons to keep it awake. But yeah, there it is. Very happy with it, and a highly recommended and cheaper substitute for the Weller irons. And oh, one thing before I forget, the tips. Bought a whole lot of tips. These are the Hacko 900 tips, which are readily available on eBay, and I got the big chunky tip when you're doing your chassis connections and tag strips and whatnot. But for your general PC boards and stuff like that, I just use the cone-shaped tips. I find around 390 degrees for PC boards and stuff like that works well, and then when I'm doing my valve stuff, I'll put it up to 420.